argument z minus z1 is equal to alpha. This also represents a certain locus. So this point z1 is actually fixed and this is actually a variable. This is also a fixed angle. Argument, it refers to a particular angle. So now let's say z1 is this fixed point, refers to this fixed point, and z is a variable. But as we have seen previously, z minus z1 is basically the line, or you can see it like a vector from z1 to z. Is a vector from z1 to z. So this actually refers to the locus of points such that z is a locus of points such that if I join z1 and z, then the angle is going to make with the x-axis, that is with the line parallel to the positive x-axis, is going to be alpha. So how it's going to look like? It's going to look like this. This is z1, this point is z1, and this is the locus of z. I cannot go below this line. Okay, so z represents all the points on this line. It can be any point on this line. Why? Because if you join z1 and this any point on this line, so the line you get, or the vector, it actually makes an angle of alpha with the x-axis. Okay, maybe let's look at a particular example. So argument z minus 3 plus I is equal to pi by 4. So 3 plus I, so let's say this is this point, and so the locus of z is going to look like this. This angle is pi by 4 and this point is 3, 1. Alright, very easy. Now let's do something. Let's just switch this to complex numbers. So instead of z minus z1, let's have z1 minus z. So z minus z1 refers to the vector from z1 to z. So now z1 minus z, let's say this is z1. So the z minus z1 is to refer to the vector from z1 to z. So z1 minus z is going to refer to the vector from z to z1. From z to z1. So z to z1. So let's say it will be something of this nature. Z to z1, such that the angle it will make with the line parallel to the x-axis is going to be alpha. So z can be any point on this line. It cannot go beyond this. So any point over here, if I join it z1, is going to make an angle alpha with this line parallel to the x-axis.